Thank you all for joining us today. I want to welcome you to TRC and GeoCam's station mapping webinar. I'm Ben Dwinal, Director of Solution Architecture here at TRC. I'm joined by Todd Slind and Myles Sutherland. So today, we're going to discuss some opportunities that are emerging in the industry that will allow you to enhance your current station data efficiently and at lower costs and with shorter timelines than traditional methods. Our group and primarily TRC, we've been exposed to this scenario over the last 8 years doing utility network migrations for gas and electric customers. And we continuously encounter scenarios where, stations or points of critical infrastructure are not mapped. And as organizations modernize, as their data becomes higher fidelity, data models become more granular, not having station data or points of critical infrastructure mapped into your GIS is presenting challenges for utilities. It creates some inconsistencies in work and assets management processes within the organizations, inconsistent reporting across your systems, reduced field visibility for your field workers, difficulties with risk modeling, having data gaps right in the middle of your most critical infrastructure points. So, today we're going to talk about an emerging approach that we've been working on with GeoCam to generate accurate station data in less time at lower cost and with technology that can also enable remote planning and inspection capabilities for your organization. We'll finish up by taking some questions from the audience. So as you think of questions, please type them into the LinkedIn live message board. We have a team watching the board. So with that, let's go ahead and dive in. So we're going to start out today looking at industry trends that are driving the importance of improving data accuracy and data completeness. A combination of pressures are expanding energy consumption, driving to higher operational efficiency and safety, along with breakthroughs in technology, are really enabling utilities to reach new levels of asset intelligence, which is really fueling improved decision-making. So current operational challenges facing utility organizations are driving some new opportunities of applying emerging technologies to solve these problems. In this first section, we're going to kind of walk through some of those challenges at a high level, and then we'll bury down to how station mapping and automated station mapping capabilities can start to peel away at some of those challenges. So it'll be a great example that can be applied across other use cases. As we mentioned, there's just increasing pressures and expectations for utility organizations today, from regulatory compliance to staff and community safety, expectations of increased operational velocity and efficiency, while also improving service and customer service and service of your assets. They're just constantly increasing pressures. And so a lot of the areas that we see this show up for utilities is operationally improving grid resiliency, reducing customer outages, reaching higher levels of operational efficiency, closing the data gaps within their systems, and then with both customers and equipment, just increasing volumes of service that is required by these organizations, driving up the need for higher efficiency. Now, in all these cases, utility organizations are really looking to improve asset intelligence with better data quality, better accuracy of their data, and more completeness within their data sets. And so they're looking for how to address these challenges. What are the best ways to find efficiencies and gains and improvements in all these areas? And it comes down to, they're all pointing to, we need more accurate data, we need more current data, and we need better tools. So here are some avenues that we're really seeing organizations use to address some of the challenges that they face heading into the future. They're looking to improve predictive maintenance capabilities. Rather than reactive maintenance programs, they're trying to be significantly more predictive in finding faults or potential faults or damage along their lines or pipelines and address those much earlier on to avoid customer outages and improving grid resiliency. They're also looking to advanced analytics. A great example of this that we'll talk about today is the use of computer vision modeling to automate not just asset inventories, but also automate asset condition assessments. We're also seeing utilities looking to be more cost effective by enabling more remote virtual workflows for their organizations, using advanced imaging and sensor data that we'll be showing today to allow more virtual site visits, reducing travel time for their staff, and increasing the visibility across their organization because they don't have to be on site to get a real world picture of what's happening. So when we look at facility mapping and automated facility mapping that we're discussing today, this is a great example of applying technology, emerging capabilities that utilities are using to address some of these challenges. So what we'll walk through today is looking at how acquisition and processing of data and extracting information using station scanning techniques that Myles is going to talk about, how all of these factors come into play for improving safety and infrastructure modernization, how it starts to enable the predictive maintenance capabilities, how it increases asset intelligence across your organization, how it allows you to apply automation to further detect conditions or asset inventories on your lines. And I would say that these are all things that can play out in many other factors. There are many secondary benefits of station mapping. However, utilities are using these types of technologies and these data improvement techniques to address a data gap that they have within their critical infrastructure, and that's at their station locations. What are the reasons why automated station mapping come into play for utilities? Well, it addresses some of the key areas of these data gaps. It allows them to streamline or improve their asset information within the critical points of infrastructure on their networks. It allows them to have enhanced reporting and maintenance planning capabilities. It improves their integration to all of their asset management and work management workflows, improves their visibility for their field operators and their maintenance planners of real-world field conditions. And lastly, I'd say it really allows them to address a risk modeling perspective that incorporates the most critical points along their network lines. Now, the concepts of station mapping have been out there, right, for a long time. A lot of utilities have wanted to get their stations mapped and into GIS to gain all these benefits. So, why haven't they to this point? There have been some economic challenges with scaling this type of technique. And really, the traditional methods are manual survey using mounted LiDAR sensors, and those are great techniques, and they have very important purposes in the industry. However, they can be time-consuming, and they can be very costly to execute, especially if you're in organizations with thousands of stations or vaults or other points of critical infrastructure you need to map. And lastly, another challenge is that operating manual surveys or manual mounted LiDAR sensors, require high cost resources to collect, process, and produce value from this data. So that's really some of the barriers that I think when Myles starts to, go through his description of the GeoCam platform, those are some of the challenges that start to peel away. So the adjusted approach really comes through in fast and easy acquisition, much more efficient than traditional methods. The data is able to be processed much faster, much easier with current techniques, modern techniques. And really the outcomes that we're after that provide significant value to organizations. Our initial focus was to scan stations to extract UN features that could be inserted into a GIS database. However, we're realizing there's a lot of secondary benefits for this type of acquisition and processing. We're looking at virtual reality viewing of stations, again, enabling higher visibility across your organization to real-world conditions at these critical points of infrastructure, and also enabling the use of computer vision to do asset detection and asset condition assessments is another area that we're seeing a lot of secondary benefits of this type of scanning. So at the larger picture, the acquisition that Myles is going to walk through here, right, gives you an opportunity to scan it in a much smaller time window, much more efficiently and lower cost. We're able to process and extract information faster and easier than we have been traditionally. And we're able to flow that data back into your primary systems, asset management, work management, and GIS to really gain or close those data gaps and gain data enrichment across the board. Great. I'll hand it over to Myles.
Awesome. Thank you, Ben. Okay, so the next stage of this session, we're just going to dig a little bit into the GeoCam technology, talk a little bit about reality capture, obviously with a focus around stations and sort of the general process of how to image, measure, map, and model out of stations. Okay, so just a bit of an introduction to our company and the technology. Ben did a wonderful job introducing some of the historical challenges that have existed in the sort of general scanning processes that have gone on. We think a GeoCam is really being a reality capture platform or system. It's built around a core technology that's focused on understanding the position and orientation of images. So everything starts first with imagery and photogrammetric techniques with us, which is a little different to traditional, say, tripod-based, station-based laser scanning systems. Some huge advantages to doing things out of the photogrammetric sort of approaches and techniques. And one of those is the ability to extract really accurate geospatial vector data to use in things like Esri's Utility Network. So at the core of this and the technology, there's really three key components we'll talk about today. The first is the camera. So our company, we design, manufacture, and distribute these cameras, the 360 cameras, high resolution imagery. They have embedded storage, GPS, a whole bunch of capability in them. Makes it really simple for anybody to go out and rapidly collect information about a station. Do some pretty smart things with the machine learning and compression inside of the cameras. The second part to the system and the technology is really this visual positioning and mapping engine that I spoke to before. This is all about how to get really accurate position both outdoors and indoors in GPS denied environments. Obviously, when you're going inside of these stations, you don't have good reliable GPS. You have to figure out where the sensor is in 3D space. And then the third part is being able to extract out and build really high quality 360 imagery that you can use inside of your geospatial systems like Esri's ArcGIS imagery viewers, extracting CAD or GIS data that's extremely accurate, and then also producing 3D reconstructions. You'll hear folk talk a lot about point clouds, or these days 3D meshes are being sort of the trendy thing related to reality capture. We produce these 3D meshes, very high quality, and from that you can extract point clouds and use that for pretty detailed CAD modeling. Okay, so on the next slide, we're just going to talk a little bit about the actual capture process itself. So the 360 camera that we design is really being built around being quite universal, being able to deploy it on vehicles of all manner, and also perform sort of ground-based captures walking, holding the camera with a monopole, using a backpack, or even maybe capturing on a bike. So you have a lot of flexibility in how the data can be collected. That's one of the beautiful things about having a 360 camera at this size. It's very easy to mount in many different ways. You know, one of the real challenges in collecting data, I mean, stations don't really have this problem, but if you're out on a road or a freeway and you're trying to collect data at speed, often you want to go at the road speed. So this camera can be driven at 75 miles an hour. Which also means that when you're working inside of a station, you can walk at any safe speed, and it's going to capture all the information you need to be able to build really accurate geospatial data out of it. The camera itself is actually running a whole bunch of smart compression inside of it. So it's shooting 12 megapixel global shutter images. You can think of this as like 3 sensors, almost like your DSLRs. So a little bit different to an iPhone or a GoPro. This is very high quality imagery designed for getting very good metric measurements and geospatial data out of it. One of the trade-offs is it's quite a big data set. So the compression runs inside the camera, and the system also organizes all of the authentication of the user of the system, uploading the data into the cloud for processing. That historically has been one of the big challenges in managing field teams, is how to get data from the field into the office. A lot of SD cards or files and things like this. This camera can just synchronize directly over your cellular network, Wi-Fi network, Starlink even, or if you're back in the office, you just dock it and it will upload directly into the cloud. Okay, so next slide here, Ben. Okay, so what do we get out of this system? Ultimately, you're getting your own street view of anything. Really immersive imagery. It's captured at a very high frame rate. Often when you're walking around a station, this will be like 5 frames a second. So at walking speed, you're getting imagery every few inches. So it's a ton of photos. One of the great things about it is that you can use it in 2D mode, where the camera is above your head and you're walking with a monopole, but you can also take it at different levels. So you can raise it up towards a ceiling, or you can tilt it upside down and collect imagery effectively, upside down at the ground level. So sort of like this image is showing here, you can get really good insight. That's been a challenge with traditional scanning systems. A lot of them were built for tripod based, or if they were a handheld LiDAR, they had to be kept level. Being able to go full 3D and how you capture gives you the ability to see all sorts of different perspectives of your assets. One of the cool things about it is that there's actually a phone that comes with the camera. That phone is used to primarily control the camera, but it also has its own camera. So the user of the 360 camera can go and snap photos with the phone. So you can get even higher res up close information about whether it's serial numbers or labels or all sorts of tags that might be on the asset, where sometimes it's just not appropriate to put the 360 camera into a really, really tight space. So we've kind of come up with a system that we think is the fastest, most efficient way for you to get into the station, get your staff to capture data without making any mistakes, and get out of there and get through as many of the stations that you have in your network as possible. I mean, you can honestly get in and out in 30 to 60 minutes, depending on the size of the station, which is extremely quick compared to the sort of traditional tripod-based capture systems. The resulting imagery, like you're seeing on the screen here, it's all heavily integrated into the Esri ArcGIS system. So in the GeoCam viewers, you can pair it with your own private web maps or web scenes. So this can come from ArcGIS Online if you're running in the cloud, or we also have the ability to deploy this entire system on premise side by side with your ArcGIS Enterprise deployment, which also means that you can self-contain this entire reality capture system with your enterprise geospatial system. Okay, so the next step of this is that we can extract data out of the photos. So I'll just get Ben to switch to the next slide. So the primary reason we actually built the company is to use imagery to extract 3D GIS data. So points, polylines, polygons, and be able to do it out of imagery without having to use the complexity of the point clouds or the LiDAR. So even though I mentioned that earlier, that we can create these point clouds and meshes from the photos, the primary thing that we do is build geospatial vector data out of these photos. This only works because we have very accurate position and orientation of each individual photo that's been collected with the camera. So you can think of it as like triangulating objects out of multi-view photos. This gives us the ability to create true 3D features, not just their X, Y, but their Z. So you can now measure heights really precisely between the different parts of the network. The actual data, when it's been captured, there's GPS, high accuracy GPS that's integrated into the camera. This is used to get real time, the person in the field can see that the GPS will be at sort of 2 to 10 centimeter accuracy when they're collecting. It can also be post-processed. So in our server, the GNSS data will be post-processed before all of the visual positioning algorithms are run. So this means, depending on your scenario and your deployment, you can get anywhere from 2 to 10 centimeter accurate data on the stations. One of the other very interesting aspects of using the photogrammetric techniques is kind of the 4-dimensional aspects of this. So this is an evolving area, but as you start to take the cameras and go back in and re-image inside of the stations, we can match, effectively align, but we're matching each subsequent scan of photos to the initial one. This really makes it simpler for the person in the field. They even have to think less about the GPS. They can just turn the camera on and away they go. We'll do all the sort of heavy lifting and matching in the server. And then when we're coming to update the geospatial data, it's much easier because it's so precise in its alignment. That's traditionally been one of the big challenges in sort of outdoor geospatial, is how do you get all these different data sets to line up over time? Our system is effectively solving for this, and it's really, really effective inside of these stations. All right, next slide, please, Ben. So just a little bit more on this, because it is a new technique, being able to extract the vector data out of the multi-view photos. You've probably seen lots of demonstrations of this. It can be done with phones and GoPros, especially when the ground is flat and the camera is very stable, right? In our case, as I mentioned earlier, you can take the camera up very high, you can tilt it on its side, so it's sort of pretty wild in where it's going in 3D space. So the visual positioning system figures out where those photos are, and lets us extract very dense information. Like in this particular facility, we're mapping and modeling thousands of pipes and all of the componentry without actually using the point clouds or the 3D meshes. If you're coming to IMGIS, definitely come see us at the booth. We'll be able to show you a bit more of the insides of how this is working. We'll be able to live demonstrate it to you. You'll be able to go extract your own objects out of the images. So if you're interested in more about how sort of the technique of this is all operating, definitely come check us out at the conference. Okay, so once we have these 3D images and we can extract out geospatial data, we can also generate 3D meshes. So I'll get Ben to flick to the next slide. This is in the same facility. It's actually just a slightly different location, but this is a 3D textured mesh. So if you're familiar with point clouds, those will be millions of points, and sometimes if they're a LiDAR system, they've been colorized, where they'll use a camera to figure out what the color is for each point that came back from the LiDAR. These 3D textured meshes are actually reconstructed out of just the raw photo. So they're coming from the exact same sensor, the camera sensor from the GeoCam, and they are millions and millions of little triangles that have tiny little images on them. So it's full 3D. From this, we can extract out point clouds at varying levels of density. This is really good when you start to put them into CAD modeling tools and you're looking to make more complete 3D shapes, whether that is not just a point and polyline for representing the pipes inside of the utility network, but maybe now your engineering teams want to look at the dimensions and represent that in a 3D CAD model. So this is one of the outputs of the system and can be easily used in all manner of CAD softwares today. The exciting part in the work that folk like Esri have been doing is now this kind of seamless way to put 3D geospatial vector data with 3D CAD data back into the GIS. So you get a really powerful way to store, organize, and manage this data for multiple users across the organization. Okay, next one, please, Ben. So hopefully this has been a little bit obvious so far in this, but I just want to point out you can measure, and we can take really precise measurements of actual physical objects out of these photos. And sometimes it's being used to actually measure the open space. Like Ben mentioned, there's lots of different use cases people can get from this data. One of those might be performing clash detection. If you're trying to figure out what equipment can move through the space, you want to measure the widths of doors or space between the assets. Often that's not represented in geospatial data. When you're creating measurements inside the GeoCam system, you can store it inside of the GIS. So you have this kind of digital record that someone can use in clash detection software and all manner of different use cases. Okay, next slide, please. So I just want to touch more on the 3D modeling side of this. It's extremely cheap and easy to deploy these cameras and get them inside of your stations and gather imagery like never before. And you might be able to look at that just from the value of having imagery for all sorts of users who would rather make decisions remotely before they rolled a truck to get on site. You can also use it to update all of your geospatial data. But historically, that was actually being done. A lot of this was being done out of tripod-based LiDAR scans, go to a point cloud, go to a pretty high level of detail in a CAD model, and then try to bring it back into geospatial. So you can see we're kind of reversing this a little bit, where you can start with imagery, get value from it, extract out vector data for geospatial models, and then now you can start to build these point clouds and meshes to produce varying levels of detail in the CAD data. So that might be that you have different engineering teams who have value from, say, a LOD 200 model that's more representative of all the objects that are there, or you might have some folk who are thinking more at a part level and want to be able to really precisely at an LOD 500 represent the parts to use in their jobs. Okay, next slide. Awesome. So with that, I'm going to hand over to Todd Slind, who's going to talk to you a bit more about the business case of this. Again, we'll be at IMGIS, so really lucky to be partnered up with the team at TRC, and come chat to us and we can show you more about the technology.
All right, thanks, Myles. Ben, next slide, please. So when we work with our customers in helping them understand how to build a business case to move from a proof of concept, they might have done a pilot, and now they're ready to kind of move into an operational mode. We have discussions around, how is this process? How are these products adding value to the enterprise? And, you know, as Ben mentioned right at the beginning of this webinar, it's really become an imperative that organizations understand the explicit detail of what's inside their stations. They're getting pressure from this, not only from their internal kind of operational needs, but also from their regulatory bodies that they need to be reporting to. So we really feel like the time is now from a bunch of different practical levels within the organization, just so they can be conducting the business that they are expected to do. Another thing that we've touched on, but haven't gone into a great deal around, is that we've come up with a process, or GeoCam's come up with a process that we've bundled into an approach that is really lowering the cost to do this acquisition and data development. So the excuses of not being able to do it because it's too expensive, or not being able to do it because it can only be done as part of a major capital effort, those arguments are kind of going by the wayside, and now these approaches are, you know, cost effective and accessible for the most part. And lastly, as Myles just walked through, once you get that initial imagery captured, there's any number of digital products that can come from that imagery. Sometimes our customers are only looking for a basic asset inventory, and maybe that'll use an AI computer vision pipeline where we're just detecting the assets from the imagery and essentially generating a spreadsheet. Oftentimes that's involving generating the vector GIS data that Myles mentioned, which will help complete a network representation in the utility network. And then we're also talking to customers who want to do 3D digital as-builting and do want to take the imagery and the digital products to that modeled representation as a digital twin of varying levels of detail. So for those three reasons, you know, there's really, you know, the time is now, and this approach is really compelling for folks. But I want to talk a little bit about, you know, how this approach benefits the organization more broadly. And one of the key things we see is the empowerment that it provides to people that are involved in fieldwork and maintenance activities. Having these digital resources to take virtual visits to stations, to prepare for their work at the station in a much more sophisticated way, to maybe avoid a trip to a station that they might have taken that puts them on the road and incurs costs associated with a trip to the field. Those are great ways that you know, we're empowering a lot of the work that's being done and has been done in more manual efforts in the past. So we're using modern mapping technology with AI, not to eliminate jobs, but to really reduce a lot of unnecessary work and allow folks to focus on where the real value can be added. Another thing that Ben alluded to is there's a lot of benefits from having the additional detail that this approach provides for the station assets, into having a higher fidelity predictive risk models, so that decision makers, operators, they can all have higher confidence in what they're seeing from the predictive risk models, and then have a better idea of how to prioritize work to mitigate and avoid the risks that those models are telling them they need to pay attention to. Another thing where there's broad benefit across the enterprise is just having good data, highly accurate data that's accessible to everyone who needs it within the organization. It's just a great way to run a business in this day and age. So it's just raising kind of the general excellence for how an organization operates and conducts its business. And then kind of relatedly, you know, everyone is seeing that there are these technologies arriving, emerging in the industry, and it's really, you know, helping drive the transformation from past practices into kind of the modern utility and the modern enterprise, and, you know, helping a lot of different aspects to asset management, whether it's from more effectively delivering services or optimizing the life cycle of assets by having better data to better manage those assets. And I guess one of the things that we used to talk about a lot is, you know, we're kind of in the process of a generational turnover of the workforce, and having this level of documentation, this level of detail in the data really can help facilitate the transfer of knowledge from the old guard to the new guard, and enabling things, I think Ben mentioned, like telemaintenance. So having that virtual visit, having those models that you can get from a desktop and see exactly what's in a station, that can help an old experienced engineer help a more junior field engineer get the work done correctly and safely. Next slide, Ben. So, I don't want to be all butterflies and rainbows in this presentation, and there's certainly some difficult questions that we've been confronted with in rolling this approach out with customers, and going from that pilot phase to the operational phase or program phase. AI gets mixed press, and particularly generative AI gotten some negative media coverage recently for hallucinations and confabulations and things. And the good news is that the AI involved in this process and these approaches is very mature. It's built on foundation models that are very purpose-built. So computer vision has been around a very long time, and we're simply training very well-established models to identify and extract assets that are edge cases from where those models were developed, but are very core to what utilities and their organizations need. We also, are oftentimes, needing to get access to sensitive facilities, and that type of work or that type of access is sometimes limited to just employees of our client organizations. That's okay. We have very extensive experience in getting our folks certified to operate in those types of environments, but we also, as I think Myles alluded to, the process of scanning and collecting the imagery is very straightforward and can be trained on lots of different levels of expertise. So that is an issue that we've confronted successfully. There's also policy and regulatory barriers, in some cases where you're introducing a new process, but the old process is kind of instantiated and codified in the books. So there needs to be some impediments to taking this new approach. Again, that can be overcome by sharing the value proposition and the improved process and results of the process that you get out of it. Since a lot of this work is done kind of in conjunction with capital activity capital construction activities, which don't occur at every station and every year, it can be a little bit fragmented in the collection. So good data strategy kind of helps confront the concern where we're just getting little points of data collection, but we aren't getting a system-wide view from the get-go. So just making sure that you've got a strategy in place so that each of these stations, as they're collected, can be stitched together into a comprehensive network. Another thing that we oftentimes confront when new technologies are being introduced is that the staff, to support their ongoing operations of the technology and maintenance of the products that result from that technology, our customers need to get their staff skilled up on those things. Again, there's a lot of great resources to bring people up to speed on AI and these advanced imaging technologies. So that is something that can be overcome as well. And then, obviously there's a strong bias towards capital expenditures, and there's a lot of interest in treating these types of acquisition projects from a capital posture. Next slide, please, Ben. So beyond kind of the high-level organizational value that we see from this approach, we've had the opportunity to talk to stakeholders at many different levels within our client organizations and across many different functions. And every one of them sees benefit from this approach, whether it's just building the digital as-built, having the critical data they need available as a digital product that can be integrated with other sources of data from across the enterprise. Huge benefits there. Having that common picture, a common understanding of the facility, super beneficial for people working cross-function. There are software functionality that require detail that may not be in the systems currently. This process can fill those gaps and unlock additional functionality like network modeling that hasn't been able to be used in the past. So another source of benefit there. Just the data quality issue itself improves safety, reduces rework, really improves the efficiency for how field work can be planned and delivered. And then we also hear from customers that there's no clear detail in their data around where the transfer of ownership happens within a network. So having that level of detail is a real benefit that comes from this 3D station mapping approach. So all in all, kind of operational excellence at many different levels of an organization across many different functions. And we've heard it firsthand from a lot of folks who we worked on these projects with. Next slide, Ben. And just to kind of end on kind of the note of capital expense treatment, one of the things that, as I mentioned, I think Ben mentioned as well, this type of work is easier to get done when it can be capitalized. And so, one of the things that we do is look at, what are some of the triggers that we can piggyback on within an organization. And anytime something is being constructed, anytime it's being upgraded, anytime some part of equipment's being replaced, anytime there's a substantial change or addition to a station, all those things can trigger the capitalizable costs that can be incurred. And so that's a great place to do this type of work. And one of the things that also kind of makes it capitalizable is that all the costs that are involved with this work, the labor piece, the materials that are required, the transportation to and from the station, and then the services to process the data, all of those are eligible capitalizable costs. So once you find a triggering event, all of the work that's associated with this approach can fall under that capitalized accounting treatment. And then there are other things that we're learning more about where kind of in support of longer term system planning is there are some accommodations for capitalizing measurement and evaluation of existing facilities. So prior to construction planning, there can be expenses and where this would qualify to do the scanning and collect the existing condition data, do some as-builting, do some of the preliminary work that will help estimate what the capital expense might be to do a system upgrade. So we're looking, how to get smarter about how those activities can be capitalizable as well. And then we're also understanding that there are activities allowed for rate case development that may, again, getting more visibility into what the current state of the asset health is, getting a consistent view across all assets within the network so that rate case development can be better informed with better data. So some of the things that we've talked about with our customers as success factors is, understanding how to design a program that can be really responsive to capital activities. So, really jump on a new commissioning project or a new construction process and doing the scanning part of that. And then, as I've demonstrated here, there's a lot of different things to consider about how you can get creative to align the scanning work with a CapEx expense. So, always be thinking creatively in that regard. And then, as I mentioned on a prior slide, to be successful, to build out a system-wide inventory and these explicit digital assets, it really begs the goal of having a data management strategy so that each of these incremental station additions can be consolidated into a comprehensive system-wide view. So I think that brings us to the end of our prepared content, and I think we are on to Q&A. So back to you, Ben.
Yeah, thanks, Todd. Appreciate that. And yeah, let's take a few questions. You've probably been seeing me look down here as Todd's been finishing up, and we've had quite a few questions come in. So I'm really happy to be able to share some of those with you. Bear with me as I kind of pull some of these up. I think let's take this first question for Myles that came in from one of our team members. You mentioned GeoCam's ability to capture both indoor and outdoor environments. What are some creative ways that utilities are using that flexibility?
Oh, good question. Yeah, I mean, you can, I guess, think about the network as like these independent components, right? So you can go just capture your station outdoor and indoors, there's value there in the facility, sort of the physical objects and stuff, but then you can also go drive very simply with the camera on a tripod or walk the sidewalks away from the station. So you can start to get more insight into other parts of the network that are feeding into a station. And so, yeah, that's sort of one way to think about it. Depending on what folk need around the facilities, then you can start to get into more dense 3D captures. Maybe vegetation is really important to you as well. So that's where sort of the outdoor around the fence line might be very important. And then I guess the piece that we didn't touch on that folk do today is that because you can take the camera upside down, you can open up vaults and underground assets and image inside of those as well. So you can start to think about the sort of underground aspects of this and sort of fuse it all together. So yeah, technically you can go get a fully complete 3D representation of everything around the station. There's as much detail as you want. So yeah, I mean, the real key to all that is the image processing. That's a very hard thing to do with just GPS. And if you're trying to figure out how to do that with just laser scanning, often you have to put different devices together, one that's built for the car, and then one that's sort of built for the indoors. So just having a 360 camera can do this is quite simple.
Thanks, Myles. Yeah, and maybe just quick add to that. I've been out with Myles and team doing some captures, and I was actually shocked how smoothly an operator of the camera was able to move in and around equipment and tight spaces inside a building on a station, right? That to me was shocking. And seeing traditional capture methods, I just thought, wow, look at all the angles and close-ups and things that the collector was able to get, and shots the collector was able to get, that in a mounted system would have been very difficult aspects of the assets to pick up. So I don't know. I was just amazed how smoothly they could move in and around equipment, tight spaces, and get great shots. So yeah, thanks. That's a great question. All right, Todd, I think the next one is for you, and this one, another live question, so this is great. Beyond cost savings, what strategic advantages come from having a living visual record of utility assets?
Ooh. Well, one of the things that we've heard is that having the ability to virtually visit a station really saves a lot of time, not only from just the costs associated with time, but in being responsive to a regulator or some other governing body that you need to be responding to. So that may be, somebody wants to know how many of a type of equipment you have deployed across your system. If you had to drive to every station to get that information, that would take you a very long time to compile a response. And so with the ability to go and virtually visit each of those facilities, you could have an analyst at a desk visiting 50 sites in a day or more and not have to, spend weeks to, physically go to the site to collect that information. So I think, just being in a posture where you can be incredibly responsive to questions that, involve whether or not you're going to receive a grant or whether or not you're going to get a rate case approved, just puts you in a much better strategic position to, move the discussion along with respect to how you can continue to invest in your system and upgrade your capital assets.
Great, thanks, Todd. Okay, maybe there's one, maybe I'll try to take this one. I think those were pretty specific to Todd, Myles. So the next question is, beyond the technical improvements, what organizational shifts do utilities need to make to actually use higher fidelity data effectively? Yeah, another really great question. Like, how does an organization prepare for this ability to have not only real world data that is current and viable, but how do they make this shift? Well, I think the first thing is really a shift in thinking for the entire organization. And what we've been doing for the last 40 years is data enrichment, data acquisition, and solving data challenges has been a periodic activity, something that you do on a schedule and you plan for. Whereas the world that I think the GeoCam system presents to us kind of flips that paradigm for a lot of organizations, and it says, hey, data acquisition and data enrichment, because of the ability to do it efficiently, smoothly, and easily with existing staff and existing people that are on the ground, now becomes a continuous activity, right? So now, rather than going through the process of rebuilding a one-line diagram every time I do a retro at a reg station, I'm just going to scan it and let the automation build out my digital assets from there. And not to mention, I have a live, living, breathing representation of the moment that change happened to the network. I have it on images. It's captured, right? That point in time is captured, and I can revisit that point in time anytime I want. So I think that's the biggest paradigm shift that I'm seeing. There's obviously technical challenges. dealing with this amount of data flowing into your system, this amount of enrichment, this amount of change, is also a new thing that utilities have to understand. And so I think a lot of times we think in terms of scales of gigabytes and terabytes, and I think this type of data acquisition is high volume if we're going to scale it across your system. And you've got to think in terabytes and petabytes, right? How do we move that much data? How do we process it? Where do we get efficient storage? We've got to have systems that can support all these things. So those are really two of the things that I think will make the biggest difference is adapting to the paradigm shifts of continuous data enrichment, continuous data acquisition, using these efficient methods like the GeoCam system. I do have one, and it's a little off the cuff, Myles. I don't mean to put you on the spot. But let me see. Let me grab this one. So this question came in. Are you still able to achieve the extraction of geospatial accurate features even when capturing in GPS denied environments?
Yeah, you can. So I guess there's a couple of ways to think about this. Most of the time you do have some GPS as kind of your effectively georeferencing, where you can get to places like 4 corners of a property, and that sort of gives you the sort of highly accurate georeferencing. And then when you capture outside and inside under trees and things like this, the visual positioning is figuring out the sort of centimeter alignment between all the photos, sub-inch alignment, I should say. But you can do the reverse of this. You could start inside. And so you might not have georeferencing other than you know the address, and that's all you care about is to know the address. You can scan inside of a room and precisely model that room. And so there are advantages to having really highly accurate GPS data, especially as these sites get bigger and bigger or more complex campus type scenarios. But it's totally valid to just go and scan in a vertical stairwell or any space, and you can accurately measure and model out of those. So yeah, would you say that that's GIS data and it's useful? You would these days. I think in the past we would have said, hey, if it doesn't have like position with it, maybe not that useful, but more and more we're seeing this being done where just knowing like the length of a room or the length of a pipe or the relative measurements to each other is quite valuable, even if it's not perfectly georeferenced. We've been scanning inside the USS Midway. I think this is a great example, right? It's a boat. In theory, it can float. In theory, it can, well, it used to move. And so you could use this technology inside of a boat and be scanning and building, indoor routing network for cruise liners. And it doesn't have to maintain its sort of accurate geospatial referencing to be useful and valuable.
Great. All right. I think one more question, maybe Todd, I'll throw this to you first, and Myles, you and I can jump in. This probably hits all of us, but let's see how this goes. And really appreciate all the questions, by the way. These are great questions. How is AI being used to automate the capture of physical assets for the GIS?
Todd, you in on that one first, or you want me to?
Yeah, I think that one should be going to Myles, but yeah.
Well, yeah, I can touch on what we do, and there's layers to this, right?
Yeah.
And inside of our own company, we're using different AI tools to build and run the company, but inside the cameras, we use AI for privacy, so we can blur out people and vehicles and things from the photos. This is, like Todd mentioned earlier, more sort of a vision model. It's also being used in the visual positioning, and is starting to get used in how to automate the extractions of objects. Still, in our case, quite simple, points and things like this. So I'll flick it back to Todd, and he can get into the next level.
Yeah, I mean, to what Myles said, we're using computer vision models to train on asset types that our customers are interested in developing data around. And, it's just adapting existing off-the-shelf foundation models like YOLO or SAM, and really just, as I mentioned, kind of just training on what would be an edge case, because these models were originally trained to identify objects in consumer photos that they'd uploaded to the cloud. So, we can utilize the massive investment that's been made in these models by the big tech firms, and really, turn that towards these use cases that our customers in the utility space have. And, it's a great situation where, we can just continue to build our library of assets that we're able to identify. And then, we're going from, with the GeoCam technology, extracting those assets out of 2D imagery, to extracting assets out of 3D imagery. So it's a really kind of interesting time right now to be in this space, because there's just so much work to be done, and so much work getting done at a really fast clip, and it's really turbocharging. AI is really turbocharging getting better high fidelity data into the hands of folks to improve their day-to-day work.
Great. Well, again, thank you all for the questions, and we just really want to thank you all for attending today. Just a reminder, both TRC and GeoCam will have booths at the IMGIS conference next week. We'd love to have further conversations, so please if you're planning to go, come and see us, stop by. As Myles mentioned, he can show you some more live demos and some additional capabilities of the GeoCam platform. Todd and I would love to talk more about some of our computer vision modeling techniques and capabilities that can enrich your data and identify assets, from photos. Our contact information is on the slide here. Feel free, if you have questions after this, to reach out. All of us would love to answer any more questions that you have. And I also do want to point out, Brittany has taken care of all the digital processing and getting us set up today. She will be having the recording of this webinar converted to a video, so that we can share it out with all the attendees. So if there's any pieces that you missed or you had to step away, you can rewatch it. We look forward to seeing you all either at IMGS or other conferences, and look forward to further opportunities to talk to you. And again, TRC will be at booth 425, and GeoCam will be at booth 205 next week. So thank you all, and have a great day.